Hello everyone. So today we are very excited to have Srikanth with us. Srikanth is the co-founder and group chief executive of Fractal Analytics. Right? Thank you for taking out time for this discussion, which is going to really be helpful for our learners.
Thank you.
So the first questions that we would want to know is that as a co-founder of Fractal Analytics, you have worked and helped so many companies institutionalizing analytics in their companies, right? What are some of the key learnings that you got from this experience?
Oh wow, that's a big question. So in terms of data science, things have changed a lot since we started Fractal back in the year 2000. The first thing we did was to actually predict customer behavior using data and math. And what we were doing was to predict customer default on credit cards and personal loans and so on. So the first thing we did was a personal loan. Idea was you could walk into a store, buy your plasma TV or whatever, and then get a loan and walk out with a TV. 30 minutes, loan should be approved. So this seems like, yeah, it should be possible. But 23 years ago, this was absolutely the cutting edge of fintech. It still probably is cutting edge of fintech. So that's what we want to enable through a scorecard. So very clear what is happening here is there is a decision. The decision is whether the customer is good or bad for credit. And I have to make that decision using the available data that I have. I may not have everything. I don't know the customer fully. All I have access to at that time was the customer's application form. And if in now we will have things like credit bureau information and so on. Back then there was no credit bureau in India. But the key point is there's a decision and there is some data that you can use to make the wisest decision possible considering the circumstances and the constraints. So that is the thing we did, and it was fascinating because what we could see was that past behavior or some things about the customer had a direct relationship with their ability to pay back on time. We are trying to guess year out or 18 months out will the customer default on their loans, and we could do that using just the data that is available. Now what you will learn here is that there's never enough data. You can always have more data, but usually data tells you a better decision than if you don't have the data. So that's one. It's always better to work backwards from a decision and then look at what data you have to solve to the decision rather than work forward from data. Many data scientists get very excited. I have so much data, I can do this, I can do that. Yeah, that's good. That excitement is good. I would say that direct that excitement to first a problem or a context, what you are trying to solve, who's the client, what decision is she or he trying to make, and therefore what does it take to make that decision. So that is, and this was the first experience of for me. And back then, you know, I was interested in mathematics. I'm a lifelong student of mathematics, and I was really interested in consumer behavior and how human beings really make decisions, how they behave. So this I found to be a magical combination of the two, and therefore I've been addicted to data science and analytics for the last 23 years because it gives you a way to use mathematics, probability, statistics, linear algebra to understand consumer behavior and then to shape that consumer behavior. It's been the fascinating thing, right? Um, so coming back to the learning, so this was the first thing that we did, and then we also worked with Hindustan Unilever back then, and we were trying to understand how people change their behavior during a recessionary time. So we went and actually acquired data, which is called the wrapper audit. It was called the repeat buyer survey. So what Unilever was doing was to collect. They would have a specified waste paper basket at home, a trash can at home, which was only for all the wrappers of the products that the customers bought. They'll buy the products, they'll throw the wrappers there, and they would collect those wrappers, and they'll know what products have the customer bought and what have they used and how much they have used. So using this data, we could see how behavior changes during a recession. So are you becoming more, offer sensitive? Are you trading down the quality of products because you don't have that much money? Or let's say you are reducing the frequency of consumption. Let's say it's expensive chocolate. You're saying, no, I can't have chocolate once a week. I'll have only once every 2 weeks. So how does your behavior change? So data offers clues into humans are doing, and that's really where all the magic comes from. That data has all this knowledge embedded in it. If only you have the curiosity and if you have the ability to tune those algorithms, you can do that. So again, coming back to, these were the early days of data science. So we were always predicting consumer behavior, but nowadays things have changed. The big lessons these days are you have algorithms and you have engineering. They have to come together. So any data scientist today, I would say that do not miss the problem statement, the decisions, like I said, understand the decision, but you also need to know enough engineering, because now you're going to deploy something at scale. Let's say you're working for a big e-commerce retailer and you are saying, based on the last 2 clicks, I should recommend the best products that are most that the customer might be interested in. Now you have to get that answer to that question in literally half a second or 0.25 seconds, and then display it to them. It requires not just algorithms, but to have the engineering muscle to be able to deliver that in real time. So if you know more engineering, you will be better off. And the last point I would say is also understanding human behavior, right? Everything is about human behavior, and the more you understand how humans really behave, the quality of your data science improves, because most often we are augmenting somebody's decision. So you have to know whose decision are we augmenting and how does she or he behave. And secondly, we are trying to drive something in an organization, so then we want data science to be adopted inside organization. Again, it's important to know who are the users, what are they doing, how will they use the product, and what are their reservations with it. I'll give you an example. We did a piece of work for a large company where we were building some kind of a really interesting real-time dashboard of their performance for them, and a lot of algorithms are going into it. It's all good, right? We were very excited because we went and presented to the client and said, look, all these things used to take you several weeks to do, and look, now with the click of a button, literally in whatever, in these many minutes or these many hours, this will all be ready. And we saw that this client was not happy. They were actually quite we could sense that the client is not happy, because there was reservation, they were pushing back, etc. And it turns out that this person used to spend all this time, it's his job. He used to spend a couple of weeks, 2-3 weeks every month doing this, and this is where he was deriving his satisfaction from the work. And suddenly the damn thing has become automated. So now if you don't understand how he was going to resist that, and how it, and we are thinking, oh, we solved a problem, we are not really showing empathy towards the user who's actually now quote unquote out of a job or out of that piece of work. So understanding all of these also helps us drive effectiveness in driving data science inside organizations. So these are some initial thoughts. It's a very good, big and good question. I can go on for the next 1 hour, but let me stop here. And
Yeah, no, but it's very interesting to know that you were working on credit default, let's say 23 years back as well. Even today, this is one of the most popular data sets that people strive to learn when they start their journey in machine learning. So you mentioned a little bit about at the end that it's also about the human element, and people are a key resource who have to think that even in the light of generative AI, right? So there's a lot of talk regarding generative AI, and then people probably losing their jobs. What is your thought on that? How is it that generative AI is going to change data science and the people around?
first of all, I will say that data science, as we know it, is changing because of generative AI. AI will disrupt a lot of industries, but the industry that it will disrupt the most is the industry of AI itself. Because if I'm a company making chocolate, I will still be making chocolate. Maybe I'll use data science to get better at making chocolate, but fundamentally, data science or AI is not going to make chocolate for me. But if I'm AI company, then AI can build the AI completely. I don't, it can completely eliminate. So AI companies will disrupt AI and certainly disrupt data science. So first thing I already mentioned, which is, if you're a data scientist, please understand engineering better. Because if you really don't get the engineering part right, if you're just doing little algorithms in a corner, it's not going to work. You have to deploy it at scale. And if you're in the logistic regression plus plus kind of a world, then I would say that understand how to write code, how to scale these and put them in real time, etc. So that is important. Uh, as a data scientist, you have to learn that. Second, a lot of the pieces of the work that you were currently doing will get automated. So you have to be you have to use those tools to automate yourself. If you don't automate, somebody else will, and at your cost. So that's a problem. So you must learn those. Secondly, I think the more the let's say the day-to-day work gets automated, your ability to drive the next level, which means you have to understand deeper understanding of mathematics and probability and statistics and linear algebra. Those are important. I've seen a lot of data scientists who are very trigger happy. They they're glorified tool operators. They're not even solving a problem. They take a data set and throw algorithms at it. That doesn't work in any world. You have to first, your value add is coming from how you frame the problem, how you solve the problem, how you understand the context. So framing of the problem becomes more important. That is the value add one. Second, you if you have to advance the algorithms, you have to really understand the mathematics behind it. So you understand probability and statistics and linear algebra and all of these things and the latest and greatest algorithms. If you're just a user of algorithm, you're just pointing a TensorFlow or a PyTorch at a data set and thinking that you know data science. No, you just know how to code or how to point a tool at a problem. To genuinely be able to solve the problem and move the science, you have to understand the business context, the problem solving, problem framing well. And secondly, you have to understand the mathematics, etc., underlying it. Three, you have to be able to write that code to scale it in real time in organizations. And four, you have to understand the human behavior in driving those success of that. So if you learn more of these things, these are more AI proof than the basic data science, which is here the x's, here's the y, let me have a function that connects the x's to the y. If that is what you think is data science, then that is gone. That is getting automated. That will get automated quite in the very near future.
Again, a question related to what we were discussing, particularly for budding data scientists when they are early into the journey. Should they be using generative AI tools to learn more or to get some codes for problems?
Sure. Look, I think there is no, certainly yes, no problem in, it's like using a calculator. Very early on, if you in your early grades, grade 1 to grade 5 or grade 6, I mean, probably your teachers told you don't use a calculator, just learn the multiplication tables. And my daughter and I argue about this all the time. She says, why do I need to learn the multiplication table? It turns out multiplication tables are important. So I think in a similar way, writing code or understanding the math and the probability, understanding the fundamentals yourself is important before you use tools to do it for you, directly do it for you, because then you're only a tool operator. I want all data scientists to move out of the tool operator mindset. That is not a successful career. It wasn't even till now, and certainly not going to be the case in the near future. So you have to really understand what is going on. And once you've understood it, then you don't, I mean, once you know enough multiplication tables, yeah, you don't have to manually multiply every time you have to do it. You can still use a calculator. In a similar way, you can certainly use any generative AI tools. Even if you're using generative AI tools, great, it can accelerate it. Try to understand what happened inside. Learn from it. If all you're focused on is getting the result, right? Can I somehow hack my way to get a result? You just be a good hacker, but I don't know if you'll be a really good mathematician or a really good AI researcher who can actually advance the science. Right. Anybody who wants to be an AI researcher or an AI engineer should have the aspiration to advance the science of this as well, not just be a glorified tool operator.
Right. Makes sense. So one concern, which is again a little age-old concern, but has been highlighted even more because of the advent of generative AI. So large complex models require a lot of data sets, right? How do companies ensure the ethical and security parts about using these large data sets?
So it's a very good question. There are it is an evolving field, and I think in fact in a lot of companies it's the other way around, which is that there's no access to data because of the fear around security and privacy and all of those things. Actually, data has become harder to get. So what we really need is a solution where we can handle the privacy, safety, compliance aspects of it in a way that meets the newspaper test. I have this thing called the newspaper test. Whatever you're doing, if you put it out in the media, even if a tough journalist were to write about you, you should feel like I'm okay. I'm doing nothing wrong. So if you have that situation, if you have handled that, let's say we're using algorithms to detect, lung cancer on a chest X-ray, right? Now you will need the chest X-ray data, but you don't need the people names data, etc. Remember that when you take a chest X-ray, it's somebody's body that's being exposed. There is a privacy issue there. But if you're using large amounts of that data and you're really not identifying with any person, it's not going to have any repercussions or implications for anyone. And if that data has been procured with users' consent, if the user has signed off on that my data can be used for research purposes in this safe way, then it's okay. So take permission, use it responsibly, and then when in doubt, don't use it. When in doubt, go ask the question and take specific permission. And sometimes you have acquired data for a certain purpose. Now GDPR says that if you use it for a certain new purpose, you must take consent again. So when in doubt, be a little bit extra cautious. But eventually, I think there are lots of these privacy preserving ways of handling data which have all emerged over the years. And I think to that extent, you should be okay. There are now new, with Gen AI, there are copyright issues as well.
Right.
Like what if some picture or some painting or something or photograph has been used to train the model. So the new considerations are, have you taken permission? So do not take data without their permission if you don't violate those copyrights. And secondly, is there a way in which you can give a fair share of the proceeds from what you have done to the people who have contributed in creating that? So those are all emerging areas. Again, I don't think we have the final answer to all of these problems. These are important issues. I would say that a large majority of situations, you don't have to get into personal data or private data. There's a lot of value in just using transaction data, using a lot of machine data, things like that, where there is really no privacy issues. Wherever you run into those issues, where you're using that, I think some of the principles that you just discussed are some things that you need to keep in mind.
Oh, sure. That's definitely something to keep in mind, that whatever images or whatever text we are using, we should probably make sure that we get appropriate considerations and hide the PIs, the personal identified information. Makes sense.
And personally identifiable information, the definition keeps changing, right? I mean, is it just a name, address, cell phone number, or there are, unfortunately, it's not as simple as that, right? So an example is in 2006, AOL released 3 months of search data. They released it for research purposes. That was their noble mission. I don't doubt their intent. Their intent was good. Here's what happened. They actually stripped away of all the person, so account number, name, address, whatever information they had on the customer doing the search, they took it out. But it so happens that when you're searching for information, you provide a lot of information in the search box. You say something like restaurants near my house, and then your address might come in, right? Or you can say these are some of my symptoms of a disease, and that may expose that disease. And then you may search for some person's name, and you triangulate some of this. Not in all cases, but in enough number of cases, you can track it down to the person who did it, that search.
Interesting.
And therefore, it's not as simple as just stripping away personal information. It is much more than that. And it is becoming more complicated. There are many studies that have been done to show that what you think is impossible to connect back to a person can be used to connect back to a person. So you have to be careful.
Right. But yeah, this was very interesting that it's not necessarily the evident PI, but there could be very hidden information which you could track down to you. Right. So there's so much happening in the world of data science. How do you personally keep track of all the developments happening?
That's a great question. I think there is no easy way to keep track of everything. Thankfully, with all our personalized news feeds that are there, they are always, the more you click, the more you are telling them what you are trying to learn. So certainly that helps, the personalized news feeds that you have access to. Secondly, you have one thing to do is to create what is called as the communities of practice. You create a little group of people who are interested in a topic, and you come together every week and discuss that topic. And everybody says, okay, this is all the stuff that I read. That's the second way in which you can really progress. If everybody comes and says, this is what I learned, everybody is learning in the process. And there's no expert in the group. Everybody is a learner in the group, right? So that works really well. Third, I work with youngsters who are doing some cutting edge work, and I try to have them reverse mentor me, and to the extent possible, I try to learn from them. That's helpful. Four is read the papers that are getting published in this space. There are a lot of research papers getting published in this space. Create news alerts for some of these and check on those. And there's some very good Twitter celebrities and LinkedIn celebrities who are posting some really good content there. Follow that. Go and get those papers and read those papers. And then if you have the ability and the time, try to implement the results of the papers. All of these things will help you keep track. Even then, with all of this, I think you're still going to be lagging behind, because that's how fast it's changing. And then I think you could certainly use the generative AI tools also to keep track. So you can use them to ask questions and sort of learn it, break it down. So certainly you can do that to summarize those documents and learn from them. So they have certainly used tech to also get better at this.
And what's interesting to see is that you're using very diverse set of information, so that will sort of make sure that you don't miss out on different sectors of information as well, right?
And certainly podcasts and YouTube. YouTube is a very good source of very good content by some very accomplished people. I, for example, listen to Lex Friedman podcast, which is really good in many of these areas. And when you're listening to some of the leading figures in this space, some very technical leaders, some business leaders, you actually get to understand. And if you really pay attention, close attention to what they're saying and reflect on that, you also tend to understand where is the world really going, because they don't always tell you, but you can infer from what they're saying. So yes, you have to be a voracious reader, consumer of content. I read 100 books a year, so you have to read books. So a combination of all of these things makes a difference. But the passion for learning has to be there, and just find different ways of incorporating learning into your life every day.
Right. Absolutely makes sense.
And certainly visit analyticswithdia.com, which is always helpful.
Thank you for that. So currently we discussed about one particular challenge that is related to data privacy. What are some of the other challenges which are affecting the data science industry?
So today, I think the big challenges are, in terms of adoption, current Gen AI adoption challenges are privacy, safety, compliance, security. They're all sounding very similar, but they're slightly different with each other. But all these are real issues coming in the way of deployment. And I think there's also some risk of backlash that also people are fearing, because if I put something out there and it makes one mistake, Bard made one mistake and Google's market cap was down by 100 billion or something like that, right? So there are high stakes involved here. So there are some customer backlash or reputational backlash, which is another concern because of which people are being careful. And then talent. There is a huge scarcity of top talent in this industry. And that is also another reason why things are not, that's one of the challenges we have to deal with in this world. So these are some of the issues.
Fair. So since you mentioned about talent, right? What is it that, again, budding learners can do to make sure that they have the right kind of talent which industry is looking for?
Yeah. See, do internships in companies. I think this is the best way for you to learn what companies really need is try to get internships with as many companies as you can and learn from them. Talk to industry experts and talk to them about what are the problems they're solving. See if you can even get a day in the life of a data scientist and see what they do, because there's a lot of gap between what you think and what happens in the organizations. Certainly read those research papers I was mentioning, implement those research papers, write that code to implement research papers. And nowadays with Gen AI, you can actually build a whole app, put it out there in the market for them to use. Try some of those experiments. And that's one way to not just stay abreast, but also exhibit the tech that you have, right? So somebody should be able to say, hey, you don't even interview me. Just look at my website and it has all the stuff that I've done. These are the papers I've written, they're the products I've published. It's just a very high, very strong credibility driver if you could do some of that stuff.
Right. So that's definitely going to be very helpful for our learners. And I hope you implement many of those strategies as well. So finally, it's a little personalized question and very specific to, again, new learners is, how do they initially judge in the beginning of their career whether data science is the right field for them?
It's a great question. I would say that if you're not interested in math, if you're not interested in statistics, probability, linear algebra, if you had trouble with those, then I would say that maybe data science is not the right career. Because even though you might get good at it, you might be able to hack through it, to become really great at something, it's better to have all of the fundamentals. Nowadays, also, I would say somebody who's not comfortable with writing code is also, I think, I wouldn't have said this 5 years back or 10 years back for sure. But nowadays, AI, analytics, and engineering and writing code have become inextricably linked. So I think really being good at writing code and wanting to write code should also be a part of that. And third, I would say is that, the curiosity and you feel like a Sherlock Holmes who wants to find patterns in data and find what is going on. And If that curiosity is naturally something that really excites you, it's good. And how you figure it out is try solving some of these problems, and do you feel, of course it's frustrating sometimes cleaning up the data, etc., but the purpose is you're solving a case, you're solving a mystery, right? It's like a Sherlock Holmes. If that whole process excites you and you feel like, oh my god, this is what I want to do, yeah, then go ahead and do the effort. It's going to be hard, but you'll learn from it. But if you feel like, you know what, I don't really get it, what is the fuss about, then maybe something else is better for you. It's not for everyone. But I would say that curiosity in understanding human behavior, that curiosity in solving business problems, that curiosity in creating products and tools that are intelligent and smart and so on, and then this fundamental understanding of math. If you have all of those, then this is a great career for you.
Right. So interestingly, I was having a discussion with a few young learners yesterday, and we were talking about this aspect about finding the right opportunities in the data science world. And I was referring to the exploitation conundrum that probably earlier in their lives, you could have a more exploratory nature and then go to a more exploratory nature at the end.
Yeah, definitely. That's true for everything in life, which is that initially you try a few things and keep narrowing down as you learn where you're enjoying, and then keep going there. Remember that almost everything is hard to begin with. So just don't look at how difficult it is or how hard it is as a barometer of where it is. So you have to give it sufficient time that you have a sense for this is working or not. Don't give up in the first time you tried something. That's true for everything in life and every subject in life as you grow up and you do your studies. But even for data science, don't give up. But as you first expand your palette and try multiple things, if you feel like nothing is interesting enough, then yeah, maybe there are so many other bright careers. Data science is just one of the many interesting careers ahead of us.
Right. So thanks a lot. Thanks a lot for this discussion. I'm sure this is going to be very, very beneficial for our learners. Thank you for taking out time in your busy schedule for this discussion. Really appreciate it.
Thank you.